Hello everyone, in this video I'll be explaining you the problem shortest and lexicographically smallest beautiful string. So the problem statement says we're given a binary string s and a positive integer k. A substring of s is beautiful if the number of ones in it is exactly k. Let len be the length of the shortest beautiful substring. Return the lexicographically smallest beautiful substring of string s with the length equal to len. If S does not contain a beautiful substring, return an empty string. Okay, so a string A is lexicographically larger than a string B of same length if in the first position where A and B differs, A has a characteristically greater than the corresponding character in B. For example, they're saying ABCD and ABCC. So here the first three characters are the same. The fourth character in this is T, but in this is C. So since T is greater, so this string is lexicographically larger than ABCC because the first position they differ in the fourth character and D is greater than C. Okay, so let's take some of the examples and understand this problem. So we have 2904, shortest and lexicographically. Okay, smallest beautiful substring. So this is the problem statement. I mean problem name. So what they've said is they'll give a string s. They'll give a string s whose length, is basically n we can say, and also they'll give integer k. So now we need to find substring, okay, and whose length has to be smallest, and also number of ones, okay, in that substring should be exactly k. Okay, no more, no less, should be exactly k. So let's try to understand example and see. So the first example we have 1 0 0 0 1 1 and 0 0 1 and k is 3. So this is string s and we have k as k is equal to 3. So what all substrings are possible? Now if you take these substring, so as you can see 1 0 0 0 1 1, we have ones, we have three ones we have, and the length of this is basically how much? 3 6, length is 6. Okay, no other substring. Let's try to find this is also one of the substring. So 1 1 0 0 1, so we have three ones and the length is 5. So this is optimal, right? Because here length is 6, here length is 5. So we'll take this one. And if you try to take other substrings, so this can be also your substring. You have 1 0 0 0 1 1 0 0. Here also you have three ones, but as they're trying to minimize the length, so you will be taking a substring who is starting with one and ending with one. Okay, so this zero whatever you're taking, it is irrelevant to the answer. It simply maximizes the length of the substring. So one thing you have observed is the substring should start with one and end with one, and no matter how many zeros are there in between, but the number of ones in the substring has to be equals to k, and we need to find the uh, smallest substring. Both smallest and lexicographically shortest is like length, and if two substring having equal length, then we have to find the lexicographically smallest. Okay, by lexicographically smallest, let's say we have a string 1 1 0 0 1, okay, where k is 3, okay, and we have 1 0 0 1 1. Now if you try to see which one is smaller, this one is smaller obviously, right? Because this value if you see it's like 11,001, but this value if you see it is 10,011. So and also like first position are equal, but second position where it differs is here it is 1 and here it is 0. Okay, here it is 0. You have understood. So how do we solve this is the question now. One thing, if you see the string length is just 100, so here the max length is 100. So since max length is 100, in order to find substring, you can find the substring in n square ways. Like you use two for loops, I from 0 to n minus 1, and you take other for loop j which start from I to n minus 1. Okay, and you will get the substring, and you need to check if the number of ones in that substring is k, then you can take that, or else you can check with other. So here the complexity will be n square, and this is acceptable because n is 100, so brute force approach you can apply, but I'll not be teaching brute force approach. I'll let you know take the optimal approach. What if tomorrow n is like 10 power 6 or 10 power 7 or 10 power 5? So in that case the brute force solution will not be accepted. Okay, so let's take the same example. We had 1 triple 0 double 1 double 0 1 and k was 3. So I'll be using a two pointer approach. One pointer I'll be pointing it here, the other pointer I'll be pointing it here, and I'll use a map. So map will hold okay, since in this string we have only zeros and ones, right? So let's not use map. If it were like all characters, then we would have used map. But in order to keep count of one, how many one has occurred, so we can take one count variable. Initially it is initialized to 0, and this let be L pointer and this let be R pointer. So we will move right pointer from left to right. So initially one count is 0, right? One count is 0. When you take this one, so here it is 1 actually, so one count will be 1. Now you will move R pointer ahead here. Okay, now you will be checking now if this one count is equals to k. No, k is 3 but one count is 1, so it is not equal, so you will move R pointer ahead. Again here you will move R pointer ahead, here you will move R pointer ahead, here you will move R pointer ahead, and your count is 2. Still you will check if both are equal, k and one count, it is not, so you will move ahead. So here if you see the uh, you know uh, both the counts are equal, I mean one count and whatever we require both are equal. So now if you clearly see, the left pointer is pointing to this one, right pointer is pointing to this one, and this is the length of the substring. Initially we will take length as some int max value, some greater value, and we'll be checking if that length is the current length, uh, the current max length whatever we have is greater than uh, the substring length that we have got. Yeah, int max is greater, and here the length is 6, so you will update answer is 6, and your answer string is gonna be 100, sorry, 00011. Okay, now since you've got this one right, now what you need to do is you need to move um I mean this is correct, I mean whatever we have done right now is correct. Now but in the code what we'll do is we'll try to make sure this left whatever we have, right? So it should point to the one only, not 0. It may happen that your string is something like that 000 1 000 0 1 1. So in that case your left will be here and right is here. Okay, and you are choosing uh, length as this thing, but you need to make sure this length, this L, is pointing to 1, starting with 1, and right should be pointing to R minus 1. Okay, so how you can do this now is the question, right? So you need to make sure you'll have to check in the condition if your this one count is equals to k, then you will run a loop while you will say if your one count is equals to k, then in that case you will move your left pointer ahead. So you will do you'll check if the string of left is equals to 1. So in that case one count, let me OC, will be decreasing and will be pointing L pointer ahead. Okay. So since in the if condition you have got OC count as k, okay, so you're into this if condition and you'll be executing this, and this condition will hold until both are equal, one count and k. So you will be at this point also it is equal, so you will move a pointer ahead, and now your one count is 2. But actually if you see your left pointer is here, right pointer is here, this is but it is not the length. Your previous one whatever you had, right, that should be included in answer in order to uh, you know I mean in order to find a beautiful setting such that in that we have number of ones as equals to k. I think I understood. So this thing will be taking here in the code. Okay, so your left pointer will be at this position, and you have found somehow the length of the string, and here if you see the count is now 2. Okay, now you will move right pointer ahead, sorry here this, then you will move right pointer ahead, then you will move right pointer ahead. Now this position your count is 3. As you can see from left to right you have 1 2 3 ones, and since L is pointing to zeros, these zeros can be redundant. This can be removed so that the length becomes minimum. So what you'll do, you will check if OC count is k. Again you'll check while loop and you'll try to move left pointer ahead. When you are at here, still you have one count as 3 only. Okay, 1 2 3. Then you'll move ahead at this position. Now your count is 2. So in that case, what you have done actually, previously whatever one you had taken, so that should be included in the answer. So whatever left is pointing, right is pointing, so your length is gonna be r minus l plus 2, right? I think you understood. Like let's say this is at 0 1 2 3 fourth index and left it as fifth index 6 7 8, but here length if you see 1 2 3 4 5, so it will be 8 minus 5 plus 2, so you have 5 length. And if we check the current maximum, which is 6, but here length you have got as 5, so obviously this one is good, so your length will be updated to 5 and your answer string will be pointing to 11001. So it's a basically two pointer approach, and the time complexity is basically 2 times of n, 2 times of n, and space complexity, since you're using just one variable, so it will be constant, so it is linear and it is constant. So I think you guys have understood how we are solving this type of problems are very easy. Let's try to code it up. So first thing first, what we'll do, we'll take n as the size of the string, we'll take left pointer, we'll take right pointer, and we'll take one count variable, initially 0, we'll take string answer, and we'll take length variable, initially it is, let's say, int max. So now you'll run a loop, you'll say while right is less than n, you'll check if s of r is equals to 1, which means you have got 1, so you'll do 1 count plus plus. Now we'll check if your 1 count is equals to k, then you will try to move left pointer ahead. So you'll say while 1 count equals to k, what you're doing, you will be checking if s of left pointer is equals to 1, then your 1 count is gonna decrease and left pointer will move ahead. And when you come out of this while loop, your left pointer will be pointing ahead of one position. So your, you can say, current length is gonna be r minus l plus 2. Now you'll be checking if your current length is lesser than the length, then in that case your length will be current length, and your answer is gonna be s dot substring of left pointing one position back it should be pointing, and whatever you know length we have, length, or you can say current length. And it may happen that your current length is equals to length, so in that case what you need to check, you need to check the which is lexicographically smaller. So you need to check if s dot substring of l minus 1 comma current length is lesser than the answer string, then your answer string is going to be s dot substring l minus 1 comma current length. Okay, and here don't forget to point the right pointer ahead and return the answer string. Let's try to run it. It is running fine. Let's try to submit. So it got accepted and beats 100% of the user. Okay, so the time complexity, as I said, is linear and space complexity is constant. So yeah, thank you guys.